Good day, guys. We are going to continue looking at integrating odd powers of trig functions for mathematics N6. And today we are looking at sine to the power 5, the root of x, the root of 3, then x dx. So, when we are integrating odd powers, the way we treat sine and cos when breaking down the power 5 is this way. I think I once explained this when I was dealing with cos to the power 5. So sine to the power 5 and cos to the power 5, that is the technique they follow, because for maths N6 on the formula sheet, the highest power of trigonometric function is the power 2. So we'll follow the technique to break it down. So that will be our first step. So I'm writing the integral of sine squared root 3x, all this square. So that's the first thing I do, multiply by sine root 3x dx. So that's my first target. So you see what I've written here looks exactly like that one. Then from there, the next step is to get the meaning of sine squared. So usually with sine and cos, I always say to get the meaning of sine squared, look at the original power. If it is an odd number, then you must be using this identity on page 1 of the formula sheet for maths N6. So this identity, I keep telling students that this identity is for odd powers of sine and cos. So you go to that identity, you make sine squared a subject, the same thing if you were looking for cos squared. So once you see that the original power is an odd number, that is where you go. But if it was an even number, you will be targeting a different identity, which is around number 7 or 8. So the sine squared will be a half minus a half cos 2a, and cos squared will be a half plus a half cos 2a. So these two are for even powers, which is to say, if I was integrating sine to the power 4, once I do this first step, I will go there. But since I'm doing sine to the power 5, which is the same thing like sine to the power 3, which are odd numbers, I go there. So let's now get sine squared, since we're fine with that. So sine squared means 1 minus cos squared from that identity. So I'll get 1 minus cos squared root 3x, all this squared multiplied by sine root 3x dx. So that is it. And from here, since it's a product, the next step now is u substitution. And with u substitution, you see there is a product that involves sine and cos. You need to know which one do you call your u so that you differentiate to get the other one. So here, since sine is standing alone, if you differentiate cos, it can give you sine. So here u must certainly be cos. But you can't say let u be sine, because when you differentiate sine, you can't get cos squared. So I will start by using u substitution the normal way. Then after I will repeat this problem with the power rule. So I will say let my u be cos root 3x. So that way du dx will be equal to, when you differentiate cos, you get negative 3 sine root 3x. Then you now need to make dx the subject so that it takes this position. So if I make dx the subject, to make dx the subject is that easy. I usually just interchange this dx here without one. I swap their positions. Once I do that, I get my dx being du on negative root 3 sine root 3x. So that is it. And if I continue my integral this side, I go there and do my substitution. It will be the integral of 1 minus u squared. So it means in the place of cos, I'm putting u, then x squared again, multiplied by sine root 3x, then my dx will replace by that one, which is du on negative root 3 sine root 3x. So here sine root 3x will take care of itself. Negative root 3 is the denominator, which which will go down as 1 on negative root 3, the integral of 1 minus u squared, all that squared. So what is now left is to open this bracket, which is one other thing I've also discussed with my mathematics students, that you need to be familiar with the expansion of a minus b, all that square, without already running around. So you just take a, you square it, you take minus b, you square that, it will give you positive. Each time you square a negative number, you will get positive. Then if you take 2 times a times minus b, it takes you to the middle person. So this is how fast you can do this expansion. The same thing goes if it was a positive sign there. You follow the same technique, you take a, you square it, you get a squared. If you square b, you get your b squared. Then in the middle, I'll get 2 times a times b. So this one works all the times. As long as you've got 2 terms, then the power is a 2. So that's the fastest way we expect any students to expand. So when I look at my problem here, this is a perfect match to the first one. So my a will be 1, my b will be u squared. So I'll do my expansion now. It takes me to 1 on negative root 3. The integral of, if I take 1 and square it, I get a 1. The middle term, I'll take the power times 1 times negative u squared. That gives me negative 2u squared. Then the last term, if I take negative u squared and square it again, each time you square a negative number, it turns positive. Then that is what you get. Then, from there, you will now need to do your integration. So we're now going to integrate. In terms of u, you integrate 1, it gives you u minus, you integrate u squared, you get 2 over 3 u cubed. Then you integrate u to the power 4, it's u to the power 5 over 5 plus c. Then we will now check what is the meaning of u again. And u is cos root 3x. So we'll now replace u by the value of u, which is 1 over 3 into cos root 3x minus 2 over 3 cos cube over 3x, then plus 1 over 5 cos to the power 5 root 3x, then plus c. So that is your final answer. If you want to leave it like that, it's okay. If you choose to open the bracket, then remember that negative 1 over 3 must multiply every term. So if you're opening the bracket, please just make sure you do it right. So I'm opening the bracket so that it multiplies the first term. Then if I open the bracket, I have 2 negatives, it becomes positive. I'll get 2 on 3 over 3 cos cube root 3x. Then if this multiplies there, that becomes negative 1 on 5 root 3 cos to the power 5 root 3x plus. So guys, that's how simple it is. So what we will do now is to repeat the same problem, now using the power rule, which I've always explained to you that it makes derivative very fast. The power rule is a formula on page 4 of our formula sheet, which we can use it to do integration of u substitution very fast. So I'm going to take you through the process for those who use the power rule, so that in case you prefer the power rule, you should be covered. So let's call this method number 2. So I'm taking the same problem. So with method 2, the first 3 steps will be the same. So I'll just copy them first. So I'm integrating sine to the power 5 with 3x dx. So breaking it down from the power 5 to the power 2 will be sine squared with 3x, all this squared, then multiplied by sine with 3x dx, just as I did the other side. Then from there, look for the meaning of sine squared. I'm getting it from the same place, so it will give me 1 minus cos squared. I guess I've explained already to you how to get to that square. Then multiplied by sine with 3x dx. So with the power rule which is here, we need to make sure we expand this until we get our 3 terms. So So the expansion we did here of 1 minus u squared, all that squared, we will do the same thing, but now in the place of u, we'll now be using our cos. So I guess that will be easy. So I will just take 1, square it, it will give me 1. Then I take 2 times 1 times cos squared for the middle term. That will give me negative 2 cos squared to 3x, which if you match it, you see negative 2u squared there. Then the last one, I take negative cos squared and square it again. If you square a negative number, it changes to a positive number. So it will be cos to the power 4 with 3x. So that's my expansion. Then I multiply it by root sine 3x dx. Then I will open the bracket again to get 3 different integrals. So with the power rule, that is what we'll do. So you take your sine, multiply 1 to get you to the first integral, which is the integral of sine root 3x dx. Then minus, if sine root 3x dx multiplies the second, you see the 2 is a constant. With integration, I practice keeping all constants outside. So I'll get cos squared root 3x multiplied by sine root 3x dx. That's my second term. If sine multiplies there, then the last term after the positive sign, you see that sine will multiply cos to the power 4. This is the 3x dx. So now that I've got my 3 terms, the first term is no problem. To integrate sine with 3x, all I need to do is look at page 2 of my formula sheet, which if I integrate, I guess it will give me cos root 3 over negative cos root 3 over root 3. So my target is this one. This is where I'm going to use this thing, the power rule. That is where I'm going to use the power rule. If I'm using the power rule, it means I'm using it where there is a product. You see, whatever I have to call my u in my u substitution, you see there's a product where I have to either choose u as cos or sine. But as I've explained before, u must be cos, because when I differentiate cos, I can create sine. But if I differentiate sine, I cannot create cos squared. So in that way, my u must be cos. So whatever my u is supposed to be, I put it in the place of f. So for this one, I'm not integrating it for now, so it will just be sine root 3x dx minus 2. Then the integral of the person I'm going to call my u, which is cos. I place it there, so that gives me cos root 3x. Then the power of cos will be my n. So my n will be a 2. When I differentiate cos, just as we've seen before, the derivative of cos root 3x is a negative root 3 sine root 3x dx. So to make sure that my u substitution is complete, you see that as we are told, when you put f there, its derivative must be here. So I've put my cos root 3x there, its derivative is here, but I must make sure these 2 are still the same. So when you compare the 2, you see there's a negative root 3 here, that does not appear here, and the only number that can take care of this is to take 1 on negative root 3 outside, so as to balance that. So with this, I'm done with my u substitution already in this part. If I were to write my answer for this part, for example, all I will need to do is just to multiply those 2 numbers outside, which will give me 2 over 3. Then, for this one, writing my answer, since f was put, cos was put in the position of f here, I will do the same thing that side. Then I will be getting my cos, the power will increase from 2 to 3. You see the power must increase by 1, 3x divided by 3. So you see that's my answer for the middle term, which if you compare it to this, is the same thing, 2 on 3 root 3. You see our 2 on 3 root 3 cos cube. So So that is the way it is. Then for the first one, it's simple because I just copied from the formula sheet, page 2. If you integrate sine, you will get negative cos root 3x divided by root 3, because in the formula sheet, you'll be integrating sine ax. Yeah, a is root 3 divided by root 3. So you see that the first term is also a perfect match. Now, if I go to the last one, usually with the last one, I don't bother myself much because I just compare what is here to what is there. If you look at these two, you see the difference is just a 2 and a 4. So therefore, the adjustment I did this side, I will just do the same adjustment this side because the difference is just the 2 there and the 4. So you must remember, my adjustment didn't involve this negative 2. I started adjusting by putting negative 1 over 3 outside. So it means if I'm doing the power rule here, I will get negative 1 over 3. The integral of, I'm just copying this and pasting here, I get cos root 3x to the power 4 multiplied by negative root 3 sine root 3x dx. So that's my simple adjustment. And then from here, I write my answer the same way I did for this one. So to write my answer, I start with a constant outside, which is 1 over 3. Then this cos, I took the position of f in my formula on the left, to do the same thing on the right. So I will get in cos to the power 5 root 3x divided by 5 plus. So these are 2 methods. So for me, I always prefer the power rule because you see how short it takes just 1 page for us to solve. But with the u substitution the normal way, you see it takes 2 pages. But if you understand that one better, then it's okay. Whichever one you prefer is the same thing. And you can see that all the 3 terms in your answers are exactly the same. So guys, thank you very much. That is it for the power 5. Thank you.